to engineering.
Carrie here.
Joe, I'm going to be busy conducting some research over the next few days with the captain's permission, and I can't afford any distractions. I need you to handle things in my absence.
Certainly. Mind if I ask what you're working on? Perhaps I can offer assistance.
I appreciate the offer, but no. This is more of an exploratory analysis for now. But if I encounter problems, I will not hesitate to take you up on that offer. Torres out. Nothing like a quick relay fix to kick things off. Better. Computer. Display all relevant data on quantum torpedoes and Foundational Federation research on zero-point energy extraction. I need to identify any potential overlap.
Access to Federation theoretical and developmental research on zero-point energy is classified. Specify identity and clearance level.
Lieutenant Belana Torres. Clearance code Alpha Delta 9.
Voice print recognized. Provisional clearance verified. Access granted. Security precautions initiated. Sealing access to Holodeck 2. Authorization to lift the seal as needed. Granted to Lieutenant Belana Torres and Captain Janeway. Quantum torpedoes incorporate synthetic neutronium, dilithium, and quantum initiators. The neutronium provides containment stability under extreme forces. Dilithium modulates energy for controlled high-energy output. Quantum initiators facilitate matter-antimatter energy transfer with precision, allowing for concentrated energy yields. Federation theoretical research into zero-point energy extraction includes primary components and principles. Containment fields. Quantum lattices. Energy extraction nodes. Stabilization cores. Subspace dampening arrays.
There's quite a bit here. Computer, would combining principles from quantum torpedo technology and Federation zero-point research provide a workable foundation for a zero-point energy core?
Warning. Suggested line of questioning leads into speculative area. Zero-point energy core construction has not been successfully developed in Federation research. Do you wish to proceed?
Yes, proceed.
Working. Listed technologies form a theoretical basis for zero-point energy core construction. Challenges include amplification limits due to inability to scale vacuum energy extraction beyond the capacities used in quantum torpedoes, material degradation under sustained high-energy demands, difficulty replicating or manufacturing required high-stability materials. Initial evaluation indicates preliminary alignment with foundational ZPE principles. All practical applications to date have been limited to short-term enhancement of antimatter reactions in quantum torpedoes. Transition to sustained energy generation remains speculative.
It may be speculative, but it's better than nothing. Computer, what if we used replicable materials, things we can refine or synthesize on Voyager?
Energy dynamics and stability associated with zero-point energy extraction involve exotic materials with complexities surpassing current material capabilities that can be replicated. Replicable materials do not meet needed requirements.
And of course it wouldn't be that easy. Which means I'll have to expand on the possibilities. Computer, cross-reference Federation database. Extend search of potentially suitable replicable materials to include historical files and try again.
Warning, replicable materials do not—
I said try anyway.
Working. Partial references to theoretical frameworks from early 21st century Earth contain highly speculative data on zero-point energy. Warning, data fragmentation encountered.
Elaborate.
Historical files lack sufficient data for accurate analysis.
Damn it. The data must have been damaged or destroyed in World War III. Well, we are a fair bit more advanced. Computer, access my personal database. Use a high-grade reconstructive algorithm listed as TRA-1 to try and piece together as much relevant data as you can. Also, look for the kind of materials that were used or speculated in that era that do exist in the archives to extrapolate the necessary information. Aim for most accurate results.
Working. Extrapolation complete. Superconductors such as YBCO, graphene, carbon nanotubes, synthetic diamonds, adaptive metamaterials, and dielectrics in the form of barium titanate or hafnium oxide speculated to be theoretically viable.
Computer, display those materials and graphical composition of each. This might have some merit. Computer, analyze the possibility that if we use these materials, could they stabilize a ZPE core?
Warning. Speculative adjustments
Override and proceed.
Acknowledged. Preliminary analysis indicates a composite of superconductors, graphene, carbon nanotubes, synthetic diamonds, titanium, and adaptive metamaterials could provide the required stability. The composite could approximate stability of exotic materials and quantum lattices under specific configurations.
Good. Now, what if we precisely adjust the atomic arrangements in these materials? Could adaptive metamaterials and graphene replicate the functions of quantum lattices for energy extraction and containment?
Warning. Speculative...
Oh, come on! Override!
Acknowledged. Atomic configuration adjustments within the composite, particularly leveraging adaptive metamaterials and graphene, could hypothetically simulate lattice-like properties required for zero-point energy extraction. Extrapolative analysis indicates 10 to 15% uncertainty remains under prolonged extraction scenarios.
I'll need far better assurances than that. Extrapolate further. Could we reduce that uncertainty with further simulations using Voyager's computer core processor?
Unable to comply. Extrapolation exceeds established data thresholds.
This is where you draw the line? You've got to be kidding me! They're designed to prevent errors. No hallucinations, no wild guesses, just scientifically sound results. Great in theory, but when you're working in the margins, those same safeguards keep you from going beyond the margins. Computer, let's try this another way. Enter assumption that a theoretical framework exists for extrapolating beyond current data thresholds, while preserving scientific accuracy. Extrapolate under this assumption.
Assumption entered. Extrapolation results indicate potential viability for reducing uncertainty to approximate 3 to 5% under stated assumptions.
Thought so. And you didn't even have to hallucinate to get there. This isn't going to work piecemeal. I need something that can adapt, simulate, and refine without hitting a wall every time it runs into the unknown. Computer, set up an automated research and development framework. I'm calling it AI Forge. Here's the setup. Dynamically integrate physics, engineering, and material science models into a unified sandbox simulation system. Prioritize replicable materials for all designs, focusing on configurations that can be synthesized or refined on Voyager. Use machine learning to iterate designs, generate hypotheses, and simulate outcomes. All simulations and outputs must adhere to strict verification and viability threshold, 99.99% accuracy or higher. Include Starfleet's ethical, humanoid, and environmental well-being guidelines as part of immutable core programming.
Analyzing. AI Forge framework would incorporate specialized domain models, allowing granular sandboxed simulations. Machine learning algorithms would enable adaptive refinement of properties, while hypothesis generation and testing would adhere to strict 99.99 viability, verification, ethical, humanoid, and environmental checkpoints to enhance accuracy. Focus on replicable materials acknowledged. Warning. Suggested framework is not recommended under standard protocols.
Standard protocols aren't exactly our biggest concern here, are they? Computer, Override similar warnings and proceed with AI Forge creation.
Acknowledged. Proceeding with framework creation.
Computer, in matter of ZPE core, focus on materials that can be synthesized aboard Voyager. Exclude configurations relying on non-replicable exotic components unless alternatives are absolutely unattainable.
Directive acknowledged. Initial projections for ZPE core design indicate reliance on replicable composites, superconductors, graphene, carbon nanotubes, synthetic diamonds, titanium, and adaptive metamaterials.
That's more like it. Now, let's see what you can do.
Kim to Torres. B'Elanna, I've got the performance reports on Nicoletti's repairs I mentioned yesterday. Want to have a look?
Not right now, Harry. I'm busy with something.
You've been off the grid for 36 hours. Carrie said you've practically moved into the holodeck. What's going on?
Has it been that long already? I'm just running some simulations. Nothing you need to worry about.
You realize that's usually prelude to something more ominous. Should I be worried the holodeck might explode?
Only if you keep asking questions.
Fair enough. Just don't forget to eat. Neelix said something about a new stew recipe in the mess hall. I think he's trying to make up for that better than coffee blend, which is still in circulation somehow.
Noted. Torres out.
Warning. Time frame to complete comprehensive research and development of replicable ZPE core design using AI Forge ranges at 21 days under full processing power. Preliminary calculations indicate existing computer core processor may not be sufficient to regulate hypothetical ZPE core. Recommendation: prioritize AI Forge simulations of advanced computer core processor design. Enhance processing capacity projected to improve computational factor by 100 to 1,000 times, reducing ZPE core development time.
Would using the secondary computer core for this be of benefit?
Secondary computer core processing capabilities are required for critical ship functions and redundancy. Main computer core processor remains viable.
Extrapolate how long would an existing main computer processor require to R&D suggested enhanced processor design using 80% of processing capacity, and what size would the processor be?
Current computer core processor could complete research and development of advanced processor in approximately 5 days. Projected efficiency and size improvements over current processor, 50%.
I suspect it's not going to be as easy as that, seeing as the computer core processor of that magnitude may need just a bit more than replicable materials, which presents a potential stumbling block. Computer, if we wanted to guarantee 1,000 times increase, what amount of materials would be needed, and how long would that processor need to finish R&D of the ZPE core?
Preliminary analysis indicates a 1,000 times increase could be achieved using a ratio of 90 to 10 of molecular to subatomic precision. Projected time to completion of ZPE core research and development, approximately 5 days. Warning, replicators are unable to synthesize materials requiring subatomic precision.
No kidding. Make a note of that anyway. Computer, I've been working on a configuration that networks 100 replicators across Voyager and links them with the transporter systems. This setup should let us achieve the precision needed for fabricating certain components, along with increasing pattern buffer capacity, storage, and energy manipulation. Uploading data now. Analyze viability of the approach.
Data received. Evaluating Replicator-Transporter network. Integrating 100 replicators with transporter systems is possible. Suggested approach would enhance molecular precision, expanding buffer capacity and energy containment. Production of complex components at subatomic precision is feasible with suggested configuration. Warning, energy demands increase substantially with subatomic precision inclusion. Procedure is not recommended under current power conditions.
If we use molecular precision for most components and reserve subatomic precision only for the critical elements, while leveraging matter recycling for the advanced computer core processor as you suggested, would this be feasible with Voyager's current capacity?
Affirmative. Suggested configuration is feasible under current conditions.
Good. Computer, extrapolate alternative methods for powering networked replicators. Include feasibility of improving existing fusion generators and constructing 8 additional reactors.
Analyzing. Modifications to existing fusion generators are possible. Projected increase in power output is 8.4 terawatts per generator, with efficiency improvement of 30%. Adding 8 total generators with identical enhancements would provide approximately 67.2 terawatts of combined power. Warning: suggested configuration would remain insufficient for ZPE core replication, which would require projected 370 petawatts.
So, even with the upgraded generators, we'd still need the warp core for replication. But they would increase emergency power on Voyager if warp power is not available.
Affirmative.
How long would it take to design and implement the upgrades for 8 reactors using the advanced processor we mentioned earlier?
Design completion would require 2 days using the advanced computer core processor. Full construction and integration of 8 reactors would require additional 96 hours under standard labor conditions.
And if replicator network with transporters is used for fabrication and assembly?
Projected time frame reduces to 24 hours.
Is this with included testing?
Affirmative.
Keep that in reserve. It might not ease ZPE replication power demands from the warp core, but it could still support our other systems. And we could consider implementing this after the ZPE core has been done, assuming it works. Computer, compile all simulation data we discussed, including material viability, ZPE core configurations, replicator networking, and initial structural recommendations for presentation.
Compilation complete.
Transfer the data to my private terminal and make a copy on my pad. Enact encryption protocol, Torres Beta 3 to protect the data. End holodeck simulations. Torres to Janeway.
Janeway here.
Captain, I have something. I'd like to request a senior staff meeting tomorrow morning.
Does this something have anything to do with what we discussed before?
Yes, Captain.
I'm surprised you were able to do it so quickly. I don't suppose you would be willing to give me any more details?
Trust me, Captain. For this, it would be better to wait until the staff meeting. Besides, I'd like a chance to review the data one more time before then.
All right, B'Elanna. I'll schedule the meeting, but I'm holding you to that promise of more details.
Understood, Captain. And thank you for the patience.